Welcome everybody to the beginning of section 4.2 and 4.3. We're looking at page 93 in the workbook, and this is the natural continuation of the work that you did in section 4.1. There you discovered that area under a velocity curve had something to do with the distance traveled by an object, and it turns out that area under curves has a number of applications in science and engineering. And so we're going to have a very detailed discussion about that problem of estimating area under a curve in this section. So let's get started with example 1 here. They give us a function e to the negative x squared. You can see the graph of that function below, and they're asking us to estimate the area under the curve using what's known as a left and a right sum. So let's start by reminding ourselves what we mean by area under a curve. Okay, I'm going to shade the area under the curve so we can see what it is that we're trying to estimate here. Okay, and the way that we're going to estimate that area is using what's called a left and a right sum. Let's start with the left sum. Okay, so the picture to the left is going to go with the left sum. To estimate that area, we start by choosing a number of rectangles. That's the n equals 2 that they're giving us. So what we're going to do is to take our interval from 0 to 2. We're going to split it into 2 equal pieces, which is going to give us 2 rectangles of width 1. Okay, and what do we mean when we say left sum? Well, it means we're going to focus on left-hand endpoints. So for that first rectangle, the left-hand endpoint would be 0. We're going to take that number 0, go straight up until we hit the curve, and we're going to take that place where we hit the curve as the height of our rectangle. Okay, and then between 1 and 2, same deal. There the left-hand endpoint would be 1. We're going to go up until we hit the curve at 1 and just draw a rectangle. Okay, so those 2 blue rectangles that we drew in, those are the rectangles that we want to find the area of, and when we do, we're going to get the left sum, which we'll write L2. And so now we want to ask ourselves, how do you calculate the area of a rectangle? Well, you take its length times its width, and in this case, we wanted to find the area of that first rectangle. We'd start by asking, how do we get its height? Okay, well, its height was obtained by taking its left-hand endpoint and plugging it into the function. We want this y value here at the left-hand endpoint, so we're going to take f of 0. And what is the width of that rectangle? Well, you can see from the picture that the width is 1, so we'll multiply by 1. We've just taken the height times the width and gotten the area. Okay, moving over to the second rectangle here. How do we get its height? Well, we're going to plug in its left-hand endpoint of 1 and multiply it by its width, which is 1. Okay, so that's what we need to calculate, f of 0 times 1 plus f of 1 times 1. And how do we get a number for f of 0? Well, we have a formula for f up here, so we just need to substitute 0 into it. Okay, and the same is true for f of 1. We're going to take 1 and substitute it into our formula. We need to calculate e to the negative 0 squared times 1 plus e to the negative 1 squared times 1. Okay, and if you do that, this is a job for your calculator. You're going to get about 1.386. There is our left sum area. Okay, so we are halfway there. And now we want to move over here and talk about what we mean by the right sum. Okay, well, we're still using the same value of n, which tells us the number of rectangles, so we're still taking our interval and chopping it into 2 equal pieces. Okay, but this time we're going to focus on the right-hand endpoint. So on that first interval, the right-hand endpoint is 1. We're going to use that as our number, go up until we hit the curve, and use that output as our height. So there's our first right sum rectangle. And then between 1 and 2, our right-hand endpoint there is 2, so we'll use that. Go up until we hit the curve, which is not up very far. Our curve is very small, so we get a really short rectangle there. And we're interested now in coming up with the area of those 2 rectangles. Notice that they hit the curve at the right-hand endpoints. That's why we call it a right sum. And so R2, we're going to get by just adding up the area of those two rectangles. So starting with this one, its height is given by the right-hand endpoint 1, so we'll take f of 1 and plug it in. Width is still 1. And then the second rectangle, its width is given by f of 2. Okay, 2 is the right-hand endpoint. And this calculation is going to look similar to the previous one, just that we're plugging 1 and 2 into our function now. So we'll get e to the negative 1 squared times 1 plus e to the negative 2 squared times 1. You can substitute that into your calculator and you're going to get 0.386. Okay, there's our right sum area. Okay, so you might have noticed from this picture that the left sum rectangles, they stick way out above the curve, and so they give us too much area, and the right sum rectangles over here, they're below the curve, so they give us an underestimate of the area. So what we can say is that the area under our curve, that green shaded area, has to be between the two estimates. That's kind of the conclusion that we can make based on what we did in part A here. Okay, so part B asks us to basically repeat this process, but to do it with more rectangles. Okay, so let's scroll up here. Okay, and what I'd like to do is to maybe do the left sum part of this together and see if you can pause the video and do the right sum part of it. Okay, so the only difference is this time they want us to use more rectangles, n equals 4. Everything else is the same. So if we look at the left sum, we're going to chop our interval into 4 equal pieces in this case. So we're going to be drawing 4 rectangles, and because it's a left sum, we're going to be interested in the left-hand endpoints. So if we start with our first interval, the left-hand endpoint would be 0, so we'll go up until we hit the curve. Okay, then we come to 1/2. That's the left-hand endpoint of the next interval. Okay, so that's going to be the height of our second rectangle. And then we come to the third interval. Its left-hand endpoint is 1. Okay, so we'll go up until we hit the curve at 1. Okay, and then 3/2 is our next left-hand endpoint. And what you might notice is where those 4 rectangles hit our curve. Notice that they hit it at the left-hand endpoint of every interval. That's why we call this a left sum. Okay, and so we are ready to calculate L4, the left sum with 4 rectangles. Process is going to be the same as above, just that we've got 4 rectangles in this case. So our first left-hand endpoint is 0, so we'll substitute that in. And what is the width of each rectangle in this case? Well, it's half of what it was above. You can see from the picture that each rectangle has a width of 1/2. So f of 0 times 1/2 should be the area of that first rectangle. Then we come to the second rectangle, and its left-hand endpoint is 1/2. Okay, we keep going. Okay, and the very last left-hand endpoint is 3/2. There's the calculation that we need to do. Okay, and notice, and just make one algebra point here, there's a 1/2 in every term, so it's customary, saves us a little bit of time if we factor that 1/2 out, and then just worry about the function value. So if we start with f of 0, we're going to get that again by just substituting in 0 to our function. Okay, then we come to f of 1/2, that's e to the minus 1/2 squared. We just continue on our way over. Okay, and then this is a job for your calculator, and when you do this, just make sure to be careful with your parentheses when you're entering this, and hopefully what you end up with is an estimate of 1.126. That's our area sum using those left rectangles. Okay, so if you like, you could maybe pause the video at this point and see what you can do with the right sum. Draw in those rectangles and estimate the right sum value. Welcome back. So, Let's do the right sum part of this together and see if we got the same answer here. So n is still equal to 4, which means we're still chopping our interval into 4 equal pieces. This time we're going to use the right hand endpoints to get our rectangles, so they're going to look like this. Notice that every rectangle that I'm drawing is going to smack into the curve at the right hand endpoint. Okay, and so we're looking for the area of those 4 rectangles to get what's known as R4. Okay, so our first right hand endpoint is right here at 1/2, so we'll plug that in. The width is still 1/2. Okay, the next right hand endpoint is 1, and then 3/2, and finally 2. So we'll do what we did up above, take that 1/2 out, and then just substitute our function values in one at a time. Okay, and you can use your calculator and come up with an estimate there, and hopefully what you come up with is about 0.635. That's our right sum area. You might notice those two numbers are closer together, 0.635 and 1.126, so both of those are better estimates of the area under the curve. And so we've got a smaller range of values. Now we can say that the exact area under the curve is between 0.635 and 1.126. Okay, so this illustrates a general point. The more rectangles we use, the more accurate we're going to get. And in the continuation of this problem in the next video, we'll increase the value of n and see that our estimates get even more accurate.